Hey everybody, I hope this video finds you well. What we're going to be taking a look at in this video is the law of cosines. This typically is going to follow the law of sines in a trigonometry unit, in this case, a high school geometry course. Law of sines and law of cosines will probably be something that are revisited in the future at maybe a pre-calculus class or a standalone trigonometry class, because this is the second type of trig application that we can use for finding missing sides or angles of non-right triangles using trigonometry. So first of all, what combination of parts are we able to use the law of cosines with? As we saw in my previous video for law of sines, we were able to use the angle-side-angle combination, the angle-angle-side combination, and the side-side angle combination to find the missing sides or angles of a given triangle. Well, with the law of cosines, we can use the most obvious one of side, side, side. Okay, where they just give you some generic triangle, but they just happen to give you all three lengths of the sides. And obviously, at that point, if they're giving you all three lengths, that means we're going to be finding an angle of some kind. And the other thing that we would be looking at would be finding our part combinations would be side angle side, where they give us two sides and an included angle. So for instance, maybe they give us this side here, and the angle included between them. That's how we would use side angle side. These would be the part combinations that we look at when dealing with law of cosines. So what is the law of cosines? There's a couple of different ways that you could write it depending on what you're given in the triangle itself. Okay, so let's look at it from side A. Okay, if we're looking at it from side A, the way that we would set up our law of cosines would be a squared will be equal to b squared plus c squared minus 2 times whatever side B is times whatever side C is times the cosine of angle A. Now, in some instances, you may want to just write it where everything is, where you say it's equal to A. Let me pick a different color here so they don't blend together. Oops, hold on a second. Sorry, they came over the intercom with some announcements here at school, but we could simply rewrite the problem here, or the law of cosines when we're finding side A. That's because they've given us side B and side C, and we know the measurement of angle A. We could just write it by taking the square root of both sides and just write it in terms of A being equal to the square root of this expression. Whichever one you prefer. Personally, I always have a tendency to go with this one. I'm not sure how I'll do it here. Maybe I'll do one example just like this, one example just like that. But that's essentially what we're looking at for the law of cosines from the given angle when you're looking for the side that is, in this case, classified as side A. So now let's look at side B. So side B is going to look pretty similar to this. We're going to say B squared will be equal to A squared plus C squared minus 2 times side A times side C times the cosine of angle B. And I'll go ahead and just toss the other one up here. We can just take the square root of both sides and say that B is equal to the square root of that whole expression. So we would say A squared plus C squared minus 2ac times the cosine of b. And the last one that we'll take a look at here will be if they give us this side here C, meaning they would have had to give us side A and side B, and the included angle in this case would be C. So here you could probably kind of guess how this last one is going to be written. Side C, I would say C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of angle C. And one more time, we'll just go ahead and put it up here with the square root. So we could say that side C is equal to the square root of A squared plus B squared minus 2AB times the cosine of angle C. Now, personally, when I'm doing the law of cosines, I prefer writing it using the square roots like I have here on the right, because we have no choice but to use a calculator when we're doing this, because we're not going to bother breaking out an old school trig table to find the angle measurement or the side length that's given to us by the cosine of whatever that angle is. Okay, so we're always going to use a calculator to do the cosine of some number or whatever it is. So since we have to use a calculator here, I just like to type this whole thing in exactly as it's written, square root included and all. But that's just kind of my preference. So now let's take a look at how we're going to actually work a couple of these problems out. Okay. So here again, you can see that they're giving us this side here and this side here, and the angle included between it. So we're clearly using a side angle side setup where we're going to be looking for this side here. So however you want to set it up, let's say that this is angle A, this is angle B, and this is angle C. So this side here where the X is, that would be side A. This side here where the 7 is, that would be side B. And this side here where the 12 is, that would be side C. Just so that way we have some reference to understand which one are we going to use. So I'll just go ahead and do the first one without the square root. And in this case, I'm going to say A squared will be equal to B squared plus C squared minus 2 times B times C times cosine of angle A. Now, I'm a big proponent of anytime you use a rule, you write it down, because if you're not allowed to use a formula chart or something on a test, or for whatever reason you don't have the formula handy, if during your practice you write it down every time you use it, it's going to mean that you understand it and remember it easier when you need to. So here, now we're going to just plug in our values here. So here, instead of A, I'm going to go ahead and say X, because that's what we're looking for, is equal to side B, which I'm going to say 7 squared, plus side C, which would be 12 squared. And then we say minus 2 times 7 times 12 times the cosine of the angle that was given to us, in this case 65. So at this point here, this is really where we just go to our calculator. We can, write out the individual values if we want to. So I guess I'll just clarify a little bit what I'm doing. Here this would be a 49. Here this would be a 144. 14 times 12, that one I don't know off the top of my head. So 2 times 7 times 12 in this case will be minus 168 cosine of 65. And I forget to square my x's here. So 49 and 144 would give me 193 minus 168 times the cosine of 65. So we have to take the square root of both sides. To undo the x squared. And either way, this is where I'm going to have to go to my calculator at that point to type it into the function, to type it into the, to actually get my answer. Otherwise, I would just stop here and say that's my exact answer. That's as far as I could go without, a trig table or a calculator that would do trigonometry here to figure out the value of cosine of 65. Now you still want to make sure that you're in degree mode because we're still dealing with degrees of a triangle. We don't want to be in radians. So I'm going to just say the square root of the 193 minus the 168 times the cosine of 65, and we hit enter. And that gives us about 11.045. So x is approximately equal to 11.045. And they're not giving us any kind of units of measure, so we don't know if it's feet, inches, centimeters, anything like that. So we'll just leave it as the number. Now the thing is that you could have gone right here and typed the square root just like this, and I'll do that. I'll do that one. I'll do it like that in the next example here, just so you can kind of see what I'm talking about. Why I kind of like using the square root stuff. Okay. So in this case, I'm going to call this side A. I'm going to call, or this angle A, this angle will be B, and this angle will be C. So that means this side here is side B, this side here is side C, and this side here at the 25 is going to be side A, lowercase. Okay. So we're looking for, in this case, the way that I have it labeled is I'm looking for side B. So I'm going to just kind of look at this one here, but I'm really going to write it out the way I have it in purple. I'm going to just say B is equal to the square root of, in this case, a squared plus c squared minus 2 times a times c multiplied to the cosine of angle B in this case. And at this point here, I'm going to just plug in my numbers, and I'll say the square root of a squared, in this case will be 25 squared, plus c squared, which would be 20 squared, minus 2 times 25 for a, times 20 for c, times the cosine of angle 108 in this case. And that is how I'm going to type it into the calculators, just like that. Okay? So, give me 1 second. Sorry about that. There is a teacher, one of my colleagues messaging me. So we're just going to go ahead and show how we're going to type this whole thing in. I'm going to say the square root of 25 squared plus 20 squared minus 2 times 25 times 20 times the cosine of 108, and I hit enter. And I will get about 36.524 for the length of that side. And I guess I should have called this x when I substituted. So here we'll say x is approximately equal to 36.524, and that is really what the law of cosines is going to be, how you're going to work it. Okay. So there's 2 more examples here where you're looking for side lengths. So go ahead and try working these next 2 problems out on your own, and then when you're done, hit play and check your work and see how it compares with mine. And how did you do? Hopefully your answers and my answers are matching. Now, one thing that some people may insist on doing, just to kind of have some consistency, Some people may want to make the longest side always going to be side C, so therefore the biggest angle that they see would be angle C. And then, because like, for instance, I always make the shortest side of a right triangle side A, but here I'm not doing that. And I'm doing that specifically to show you that as long as you can identify the sides correctly, then you should be able to set up the law of cosines fine. But if you like, you can always make the shortest side A, the middle length side B, and the longest side of the triangle side C, so that way you know how to set up your angles as either angle A, B, or C also. That's just kind of up to you. It's a personal choice when you work out the problem. But that is the examples that we have for looking at how we find an angle or a side length. Now we're going to talk about how we find an angle measurement. So here off to the, before I do any of the work here for the actual problems that we have, let's see what the algebra does to show how we actually get some angle measurements. Okay, so for instance, what we saw on the last set of examples, if we said a squared would be equal to b squared plus c squared minus 2 times a times c times the cosine of angle A in this case. Well, if we wanted to find the angle, which is exactly what we're being asked to do here, because you can see we have a side-side-side combination, okay? How do we actually get the angle by itself? So what we're going to do is I'm going to take this negative 2ac, this whole thing is all being multiplied, so it's all going to produce one number. So I'm going to move it from the right side of the equation to the left side of the equation. And at the same time, I'm going to take this a squared and I'm going to move it to the right side. So that'll give me a negative, I'm sorry, not a negative, the negative's gone. We have a positive 2ac, and oh, and I wrote it down wrong. Somebody's yelling at me here. This is bc. Negative 2bc times the cosine of a will be equal to b squared plus c squared minus a squared. So we still got to get cosine of a by itself, so that way we can do the inverse cosine to get a. So b, or the 2, the b, and the c, those are just three different numbers that are all being multiplied here. So what I'm going to do is I'm going to divide both sides by those three terms that are being multiplied. We would divide by 2bc here, divide by 2bc here, and we're going to get the cosine of angle A to be equal to b squared plus c squared minus a squared over the product of 2 times b times c. And at this point, just like what we did with right triangle trigonometry or with the law of sines, if I want to find the measurement of the angle here, this is where I do the inverse cosine in this case. And I'll say angle A will be equal to the inverse cosine of b squared plus c squared minus a squared, all of it divided by 2 times b times c. And we could do that with any of the problems, or with any of the three ways that we could set up the formula for the law of cosines. We could just memorize this if we needed to. However, this can always be derived. If we remember this bit here, we could always do the algebra to get this bit here. But I'm going to just go ahead and write out the other two here, just so that we have them in case anybody wanted them. So depending on how you set up your triangle, angle B would be found by the cosine inverse of, in this case, it would be a squared plus c squared minus b squared all of it divided by 2 times A times C. And the third one, if again, depending on how it's set up, if I find that I'm looking for angle C here, I would say the inverse cosine of A squared plus B squared minus C squared, all of it divided by 2 times A times B. So these are the three ways that we could rewrite law of cosines depending on what we have and find the value of our angle that way. So let's take a look at the first one. The first one, I'm not going to use the little shortcut here that I've shown you, although you're welcome to try it if you want to. I'm going to just do the actual algebra. How would we actually get there using the law of sines? So here, let's go ahead and label everything. So I'll say this is angle A. I'll say this is angle B, and I'll say this is angle C, so that way I can actually have the longest side and the longest angle and the biggest angle being side C, and the smallest side and the smallest angle being side A, kind of like I was mentioning a moment ago. So according to the law of sines, we would say that A squared will be equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. So now you have the choice. You can either derive what we have here before you substitute your numbers, but I know most of us are probably going to just start substituting our values here. So in this case, we'll say 7 squared is equal to B squared would be 11 squared plus 12 squared minus 2 times 11 times 12 times the cosine of A. Let's see what we get here. So this will be 49, and 121 plus 144, 11 squared plus 12 squared will be 265. And the 2 times 11 times the 12 will be minus 264 times the cosine of the angle that we're looking for. So, and I probably should have put x here because cosine of x, not cosine of A. Then we move the 265 over through subtraction. So 49 minus 265 will give me a negative 216 here to be equal to a negative 264 times the cosine of x. At this point here, let me go ahead and show you so that way nobody gets lost what I'm doing with my division. Here we're dividing this by negative 264. Same thing here, negative 264. So on the right side, the 264s are going to simplify to be 1. So I'm left with the cosine of x is equal to, what is 216 over 264 simplified to be? That would be 9 to 11. Or you could just leave the ratio since, I mean, we're going to have to use a calculator to get the angle anyway. So at this point, I would say that x will be equal to the cosine inverse of 9/11ths. And this is, this is where we would stop if we wanted the exact answer, but we'll go ahead and get the approximate answer here and say cosine inverse of that ratio, and I get about 35.1 degrees. 35.1 degrees. So the second way that I'm going to show you is I'm going to just use the shortcut method. where I actually have the angle already solved by itself, and I'm going to just set up my problem this way. So let's label things. Okay, and here I'm not going to pay any particular attention to how I'm labeling this. I'm going to say this is angle A, angle B, and angle C. So this side here will be side A, this side here will be side C, and this side here will be side B. So in this case, we're looking for angle A again. So okay, we just worked out to be the same, basically the same thing that we did a second ago. So here, according to what I have written down, is I'm going to say that angle A will be equal to the inverse cosine of, in this case, b squared plus c squared minus a squared, all of it divided by 2 times b times c. So plugging my values in this case, angle A is x. That's what we're looking for. So here I'm going to say inverse cosine of b squared. In this case, b squared will be 16 squared. C squared will be a 24. And a squared, I'm going to say minus 35 squared. And all of it is divided by 2 times 16 times 24. And this is where we go to the calculator and just let the calculator kind of do the work for us. Okay, so here I'm going to say inverse cosine, and I'm going to hit my little ratio button so I have a numerator in the denominator. It's easy to type in, so I'm going to say 16 squared plus 24 squared minus 35 squared, all of it divided by 2 times 16 times 24. And we'll go ahead and hit enter. And in this case, we get about 120.8 degrees. So x approximately equal to 120.8 degrees. And this is how we're going to use the law of cosines to find an angle measurement. We can either take the generic law of cosines that we have, plug in our numbers, do our algebra by isolating the variable that we're looking for. In this case, we got to get cosine of x by itself. Then we do the inverse of cosine, so that way we can actually find the angle measurement. Or if you remember what the rule is to set it up just from the get-go, you can just plug in your numbers and go straight to the calculator to get your answer. So here are the last two examples where we're using the side setup to find the missing or to find an indicated angle using law of cosines. Go ahead and work these problems out and on your own, and when you're done, hit play again so that way you can see how your work and my work compare. Alright guys, how did you do? Here are the last two. Now you can obviously see that I'm kind of a fan of having the problem worked out in advance, where I just have to substitute the numbers. And in the first case, I'm getting 53.8 degrees based off of how I labeled the triangle with my angles A, B, and C. And on problem number 8, I'm getting about 32 degrees, again, based off of how I labeled the triangle I was finding for angle B. But ideally, you're getting the same values that I am, and if not, let me know so we can see what you're doing. But that's going to wrap it up for this lesson here. This is essentially the last thing that we will do in trigonometry as far as it relates to a high school math course. I'm sorry, a geometry math course, not necessarily high school. Because again, in pre-cal or in a standalone trigonometry class, you will see this stuff again, and you'll do a lot more things with trig functions, the unit circle, and graphing them, graphing sinusoidal functions, and a whole bunch of stuff. But this will essentially be the last trigonometry thing that we do in geometry. So until next time, guys, thanks for watching. Take care, and I hope you're all good. Talk to you later.